Good day, I am Mikel Galdones, and for my second laboratory exercise in data communications and networking one, I have been given another task to be done in Cisco Packet Tracker, and this time I was asked to create or illustrate the different network topologies in Cisco Packet Tracer. And yes, so obviously it would take a long time if I did it here in video. So off camera, I had already done what I was supposed to do, starting with the tutorials, the how to connect two devices, network devices, to a switch or a hub, and these are my outputs for the various network topologies. So first, this is the bus topology, and you can see there are five PCs and three laptops connected to eight individual switches of their own, and these eight switches are interconnected with each other through a common medium or cable or a common media. And then this is the star topology. As you can see here, there are three PCs connected with three laptops, and I wasn't able to connect the other two PCs since the hub only accepts six connections to six fast Ethernet connections. So yes, these two PCs will be left outside. And then this is my ring topology. One individual switch for each device, so for five PCs and three laptops, but the switches are interconnected in a ring formation, hence the name ring topology. And then this is the mesh topology, where there are multiple connections, not just I basically followed the same configuration as the ring topology, except there are multiple connections between the switches as well. So that is a mesh topology. And as you can see, we will talk about this later, about the green and the red light, or no, sorry, the amber light. And as you can see, the middle wires over here, which are just basic power connections, they are in red, or they are in amber. Sorry, I keep mixing that up. They are in amber, and this means something. So let's see if I can still improve on this mesh connection, or this mesh topology by I made a mistake there. By doing this, and as you can see, there's another amber lighting that opens up. But nevertheless, there's not it isn't that big of a problem because we will discuss what an amber lighting and a green lighting means later. So as you can see, I am doing this, just adding more connections to the topology, the mesh topology, and let's delete them right now. And then after this, we can move on to our final topology, which is a hybrid topology. I did not overcomplicate for this one. I just simply chose a simple, a basic bus topology connected to a hub, and then this hub is itself connected to a star topology type of configuration with still five PCs, three laptops. There are three switches here, and yes, this is the central hub. And so now we can answer the questions. So the first question is related to what I was saying a while ago about the lights, the amber lights and the green lights. So what do they signify? So an amber light on a device interface usually indicates that the device is either in a state of negotiation, the interface is administratively down, or there is an issue with the connection. So in my case, in the mesh topology a while ago, the lights were amber because there was a state of negotiation regarding the direction of where the data will go, or the direction of the data, which routes it will take. So since there are many connections, there is a negotiation occurring, and of course the first lines that I put there, the ones in the ring configuration before I added the additional ones, that will be followed first, since that was placed first, and it was illustrated by a green light. So speaking of green light, what does it mean? It means that it is good to go since the port is operational and the connection is active. So with the green light, that means that data frames are being transported towards the various devices, the network devices, and the end device and the intermediary devices. While the amber light means that the transmission is stalled between those devices since either it's in a state of negotiation or the interface is down through for administrative reasons. So number two, um, in question number two, we were asked to differentiate a switch and a hub. So a switch operates usually at data layer 2 of an OSI model. And so its function is to initiate progression of data frames between devices based on MAC addresses, allowing for more efficient network traffic and reducing collisions. Meanwhile, a hub operates at the physical layer, which is layer 1 of an OSI model or an open systems interconnection model, and it broadcasts incoming data to all connected devices regardless of the destination. So a switch um, a switch reduces connections and allows for more network traffic, and because it is actually it can actually be interchanged the direction between the devices. So if a switch is programmed to flow a certain way, for example, if it is programmed to flow the right way in the network topology, then the data frames will flow towards the right, while in the if it's programmed to flow in the left way, it will flow left or incoming and outgoing. Meanwhile, the hub always broadcasts incoming data to all connected devices. So when data comes in, the hub's task is to broadcast it or send it outwards to all devices that are connected to it. So there is no change of direction there. There is, let's say, there is one input, and then since a hub has about six fast Ethernet ports. So let's say there is one fast Ethernet port that is um, collecting the input, and the other five are all broadcast, and it cannot be reversed the direction of that. So that what happens there is that there are more collisions of data frames, and as a result, network traffic. There is some network traffic because of these collisions of data frames. So we're done with question number two. Question number three asks us which network topology uses only a single medium, a medium referring to a cable. And the answer for that is very easy, as it is the bus topology, as we could see a while ago. All of the switches were in one line, meaning that they shared a single cable or a single medium. So, in a bus topology, the data transmitted by one device is, of course, available to all devices connected to the network. Then, finally, um, for my conclusion, well, this laboratory activity was a success, and therefore I conclude that it was very effective in helping me understand how network devices interact under different topologies. And I was also able to observe the role of switches and hubs in managing traffic under these topologies, and also the green and the amber lights also helped me understand or identify and be able to troubleshoot or correct connection issues between various devices. So that wraps up my documentation for my second laboratory exercise in data communications and networking. Thank you for watching.